Imagine a machine so powerful that it can peer back in time, 13.5 billion years ago, toward the very first stars and galaxies that ever existed. A telescope that doesn't just look at the universe, but looks into the origin of existence itself. But here's the twist. This machine isn't science fiction. It's real. Floating silently, 1.5 million kilometers away from Earth, shielded from the sun by a tennis court-sized sun shield, and colder than the darkest winters on Pluto. It's called the James Webb Space Telescope, or JWST. And it's not just a telescope. It's humanity's boldest attempt to answer the oldest question we've ever asked. Where did we come from? The story of JWST doesn't begin in space. It begins in 1989, in a conference room filled with scientists, engineers, and dreamers. The Hubble Space Telescope, still awaiting launch at that time, promised to change astronomy forever. But even before Hubble reached the sky, astronomers were already thinking of its successor. Hubble would allow us to see further than ever before, but it had limitations. Hubble sees mostly invisible and ultraviolet light, what the human eye can see, plus a bit more. But the early universe, the faint whispers of the first galaxies, they were hidden in infrared light, stretched by billions of years of cosmic expansion. If humanity wanted to unlock the true beginning of time, it needed a machine that could see in infrared with mirrors far larger than Hubble's. In 1996, NASA officially began the journey to create what was then called the Next Generation Space Telescope. It was renamed in honor of James E. Webb, the NASA administrator who guided Apollo to the moon. But this dream came with an almost impossible challenge. How do you build a telescope the size of a house, make it light enough to launch on a rocket, fold it like origami, and deploy it flawlessly in the vacuum of space, with no possibility of repair? JWST's heart is its mirror, 6.5 meters across, nearly 3 times the size of Hubble's. But a mirror that large couldn't fit inside a rocket, so engineers designed it as 18 gold-plated hexagons folding into a compact shape during launch. The sun shield, another masterpiece, spans the size of a tennis court, made of 5 ultra-thin layers of Kapton film. Each layer is thinner than a human hair, yet together they block heat from the sun, earth, and moon, keeping the telescope's instruments at a frigid 233 degrees Celsius. And then, the orbit. Unlike Hubble, which circles Earth, JWST was sent to Lagrange Point 2, a delicate gravitational balance point 1.5 million kilometers away. Too far for astronauts to reach, but perfect for an unobstructed view of the universe. The risk was enormous. One wrong move, one tear in the sun shield, one failed latch, and $10 billion would vanish into space. December 25, 2021. While the world celebrated Christmas morning, a rocket launched from French Guiana, carrying humanity's most ambitious telescope into the sky. What followed was a month of pure tension. Over 344 single points of failure stood between JWST and success. Engineers and scientists watched as step by step the telescope unfolded. The sun shield stretched, the mirrors aligned, the instruments cooled. Against the odds, every move worked perfectly. By January 2022, JWST had reached its orbit, and by July the first images arrived. They weren't just pictures, they were portals. The first deep-field image stunned the world. Thousands of galaxies, each one a cosmic city of billions of stars, captured in a single frame. Some of them existed just a few 100 million years after the Big Bang. JWST didn't just look farther, it looked deeper. It revealed exoplanet atmospheres with water, carbon dioxide, and methane, hinting at potential conditions for life. It mapped the birthplaces of stars hidden inside clouds of gas and dust. It dissected galaxies, revealing structures never seen before. Suddenly, questions that seemed beyond reach began to feel tangible. Could we detect signs of alien civilizations? Could we watch galaxies form in real time? Could we even find clues to how life itself began? Behind the golden mirrors and billion-dollar price tag is a story of human persistence. JWST faced endless delays. It was supposed to launch in 2007. Instead, it launched in 2021. Budgets ballooned from $1 billion to over $10 billion. Congress nearly canceled the project in 2011, calling it a money pit. But scientists fought back. Nobel laureates wrote letters. Astronomers marched in support. They knew that canceling JWST would mean losing not just a telescope, but a generation's chance at discovery. And so, after decades of struggle, setbacks, and breakthroughs, JWST became real. But here's the unsettling question. Have we built something so powerful that it could also unravel everything we thought we knew? Already, JWST's images are challenging our theories. Galaxies that should not exist so early after the Big Bang do exist. They're bigger, brighter, and older than our models predicted. Did we misunderstand how fast the first galaxies formed? Or could it mean that our very understanding of the universe's birth is incomplete? Some astronomers whisper about cosmic surprises waiting to be uncovered, mysteries that could rewrite physics itself. JWST might not just answer our questions, it might force us to ask new ones. The James Webb Space Telescope is more than a machine. It's a mirror, not just of the universe, but of ourselves. It reflects humanity's hunger to know, to explore, to dream beyond the horizon. We built it with trembling hands and we launched it with hope. And now, as it peers into the abyss, it whispers back to us. You are part of this story. The galaxies it captures aren't just distant specks of light. They are ancient echoes of our own beginning. Every star, every planet, every atom, including you, was born from the same cosmic furnace. So as we look at JWST's images, we're not just looking at the past. We're looking at the blueprint of existence itself. And maybe, just maybe, we're looking at the first steps toward answering the ultimate question. Are we alone?